Hello friends, welcome to another tutorial in network analysis and synthesis. We're doing graph theory and today we'll find out the number of trees in a graph. Now, trees of a graph are subset of a graph and there are special properties of a tree deriving out of a graph. For example, a tree would touch all the nodes of a graph and the number of branches in the trees are one less than the number of nodes, and there are no closed paths in the trees that have been discussed in the previous tutorials. These are theoretical properties of the trees, and we know the formulas for the twigs, and if the number of nodes are n, the number of twigs will be n minus 1 and number of links will be branches minus twigs. So we know the properties of finding, or we know the formulas for finding twigs and links, but there is no concrete formula that we have discussed so far to find out the number of trees in a graph. We've been doing it as a kind of a riddle. We used to draw the twigs of a tree that would touch all the nodes without making a closed loop to find out various trees, but there is a concrete formula for that. And if we want to find out the total number of possible trees of a graph, it is given by the determinant of matrix A into transpose of matrix A. Now please understand, this matrix A is the reduced incident matrix. Please understand the incidence matrix of a graph is the sum total of all the connection that a graph makes, and if we eliminate one row out of that incidence matrix, it will become a reduced incidence matrix. It does not matter what row we eliminate, we just simply need to remove one row out of the incidence matrix to get the reduced incidence matrix. And the transpose of this reduced incidence matrix is AT, and if you multiply these two and find the determinant of that matrix, will get the total number of trees. For example, if you were given the reduced incidence matrix of a graph over here, so this is already a reduced incidence matrix. Please understand, one row is already eliminated from this matrix. So we need to find the number of possible trees. In the first step, we'll find AT. Transpose of this matrix will be rows and columns interchanged, so it will become 1 0 minus 1 1 minus 1 0 0 1 minus 1 0 minus 1 0 0 0 minus 1 1 0 0. And we know the formula, so total number of trees will be determinant of this A matrix, which is 1 1 0 0 0 1 0 minus 1 1 minus 1 0 0 minus 1 0 minus 1 0 minus 1 0 multiplied by our transposed matrix. So it will be 1 0 1 minus 1 1 minus 1 0 0 1 minus 1 0 minus 1 0 0 0 minus 1 1 0 0. So what we do to multiply two matrices, we multiply this row with this column, and of course adding the elements, multiplying 1 into 1 plus 1 into 1, then 0 into 0 plus 0 into 0, 0 into 0, and so on. So what we get as determinant of the matrix after multiplication, I'll write down the result. It will become this. And now finding the determinant is pretty easy. 3 into this and minus this, 9 minus 1, then I get to the next part. So calculating the determinant, we get 18, so the number of possible trees are 18. So if we are not given with the graph, or we were to draw the graph from a matrix, we need to calculate first that how many number of trees are possible, and then we can find out those configurations of trees so that we don't miss out on any. So this is pretty important from the point of view of multiple choice questions and small answer type questions in university examinations. And I hope this quick tutorial was of help and you liked the video. I'll start up the tie set matrix and the cut set matrix in the next video. Till then, take care and bye bye.